right, you guys had the quiz review. So the mean value theorem is allowed to be abbreviated to the just the MVT. So it is an acceptable abbreviation you can use on the AP exam in terms of justifications. And what the mean value theorem states, the conditions of the mean value theorem is that, first of all, your function has to be continuous on a closed interval and differentiable in this open interval. So that's the hypothesis of the mean value theorem. So anytime you are talking about the mean value theorem, you must state that f of x is continuous in the interval and it's differentiable in the interval. Then what the mean value theorem says is that there is at least one point C. So when they talk about this point C, that is an x value. So we're talking about there exists at least one x value in AB such that f prime of C is equal to f of B minus f of A all over B minus A, which hopefully you recognize as the rate of change, your slope formula. So let me visually describe what this means. So first of all, you have these 2 points on a function. You have point A, f of A, point B, f of B. So when you draw, this would be a secant line because it's going to intersect your function at 2 points. And you look at the slope of that particular secant line. What the mean value theorem states is that as long as your function is continuous and differentiable in this particular interval, then there exists at least one point C, which is an x value, where the slope of the tangent line will be equal to the slope of the secant line. So that's what you're looking for. We're trying to figure out what is this particular x value, where the slope of my tangent line is equal to the slope of my secant line. Does that make sense to everybody? That's what the mean value theorem states. There may be more than one place where the slope of the tangent line is equal to the slope of the secant line. For example, here's my secant line connecting point A to point B. Notice at point C1, I have a slope that is equal to the slope of that secant line. Notice at point C sub 2, I have another place where the slope of my tangent line is equal to the slope of the secant line. All right, so any questions visually about what we're trying to find? All right, so now let's take a look at a problem. So verify the hypothesis of the mean value theorem, are satisfied on the given interval, and then find all values of C. Again, remember, C are your x values. And we're only looking in the interval that's provided that satisfy the conclusion of the theorem. So f of x equals 5 minus 4 over x, and again, my interval is going from 1 to 4. So first of all, you must always state the hypothesis of the mean value theorem. So there's 2 conditions you have to state. One is that your function, in this case f of x, is continuous. And the interval that we're checking is 1 to 4. So I know that 5 minus 4 over x, it is a rational function. So I know the only place where it's not going to be continuous is at x equals 0 because we have a vertical asymptote. So I do know that it is indeed continuous in this interval from 1 to 4. Right? So the second condition is that f of x is differentiable. And again, in your open interval 1 to 4. Again, I know that in order to be differentiable, it has to be continuous, which I know it is in that interval from 1 to 4. There's no asymptotes, there's no sharp points, there's no jumps in that interval from 1 to 4. So now let's talk about the conclusion. Remember, what we're trying to find is we're trying to solve for a particular x value or some c value where the slope of my secant line will be equal to the slope of my tangent line. So the first thing I'm going to want to do is, first of all, let's figure out what my derivative is going to be. So I know in order to calculate the slope, I'm going to need the derivative. So when I take the derivative of 5, that's going to give me 0. So what's the derivative of negative 4 over x? Remember, you can rewrite this as negative 4x to the negative first, negative 4x to the negative second, or negative 4 over x squared. It would be positive 4. Right? Yeah. So then when I want to solve for a particular c value, I know that f prime of c is going to be equal to 4 over c squared. Well, in order to figure out at what particular c value will the slope of my secant line be equal to the slope of the tangent line, I've got to know what the slope of that secant line is. So what I'm going to do is, using these particular endpoints, I'm going to calculate what the slope of the secant line is going to be. So the slope of my secant line is going to be equal to my f of 4 minus f of 1 all over 4 minus 1. Doesn't really matter which step you do first, 1 or 2. It doesn't really matter. But you know you have to find what the actual slope of the secant line is going to be, as well as the derivative. So now f of 4 I can find by taking 4 and plugging it back into my original function. So what is f of 4 going to be equal to? F of 4 will be equal to 4 minus, what is f of 1 going to be equal to? 1 all over 4 minus 1. So then what slope am I going to be? 1. So my slope is 1. So I want to know at what particular x values or what particular c values will I end up with a slope of 1. So now that I know my derivative, I know the slope of this secant line is 1, then all I'm going to do is I'm going to take my 4 over c squared, which is my f prime of c, and set it equal to 1. So 1 is going to be equal to 4 over c squared. So I cross multiply, c squared is equal to 4. What's c going to be equal to? C will be equal to what? Plus or minus 2. So negative 2 and positive 2. Now what you want to make sure is, remember, you're only looking for x values in your interval 1 to 4. So which one of these values can I reject? Negative 2, because that's not in the interval. So the only place where the slope of my tangent line will be equal to the slope of the secant line is when c is equal to 2. So any questions on the mean value theorem? Okay. There is a special case of the mean value theorem called Rolle's theorem. So think of it this way. You have your mean value theorem, looking at a Venn diagram. A special condition of the mean value theorem is called your Rolle's theorem. So it is a mean value theorem, but it has a special condition. What the Rolle's theorem states is you still have to meet all the conditions of the mean value theorem. So in other words, you've got to be continuous in that interval. You have to be differentiable in that interval. But the third condition is that your f of a has to be equal to f of b. So what that means is that when you have this condition where f of a is equal to f of b, what happens is you end up with a horizontal tangent line, which means you're going to end up with a derivative equal to 0. So Rolle's theorem is basically where you're trying to find where the x value, where the derivative will be equal to 0. So that whereas we just did an example of mean value theorem, we were looking where the slope was 1. We were trying to find where the x values had a slope equal to 1. So like I said, you're looking for a horizontal secant line. That's what happens when these two y values are the same, or equal to one another. So like I said, Rolle's theorem is a special case of the mean value theorem. And like I said, if f of a equals b, then there's a place where the slope of the tangent line is horizontal. And again, in other words, the slope of your tangent line is equal to 0. So again, here's my points. There's my f of a. There's my f of b. Notice when I draw my secant line to those two points, I end up with a horizontal secant line. So again, I'm trying to find the place on the graph where I have a horizontal tangent line. Again, just like I saw with the mean value theorem, you may have more than one c value where you have a horizontal tangent line. But as long as the conditions of the Rolle's theorem are met, you have at least one. So, for example 2, verify the hypothesis of Rolle's theorem, and then find all the values of c in that interval that satisfy the conclusion of the theorem. So your favorite trig. So first of all, they want you to verify the hypothesis of Rolle's theorem. So again, the first two conditions that we did for the mean value theorem also must hold true for Rolle's theorem. So first of all, f of x is continuous over your closed interval pi over 2 to 3 pi over 2. which I know my sine curve is continuous for all real numbers. There's no holes, there's no asymptotes when I graph sine. 2, f of x is differentiable. And again, from pi over 2 to 3 pi over 2, which I know sine is differentiable for all real numbers as well. There's no sharp points, there's no holes, there's no asymptotes. So now the third condition for Rolle's theorem that you have to state is that f of pi over 2 is equal to f of 3 pi over 2. So when I go to calculate the sine of pi over 2 divided by 2, that's actually the sine of pi over 4. And I'm checking to see if that's equal to the sine of 3 pi over 4. Well, what is the sine of pi over 4? Sine of pi over 4 is, you take square root of 2 over 2. What's the sine of 3 pi over 4? Square root 2 over 2. So you know that that third condition is met. So the conclusion then, since f of pi over 2 is equal to f of 3 pi over 2, that I'm trying to find the c value, I want to know where f prime of c is equal to 0. So you don't need to go through using that slope formula like we did with the mean value theorem, doing that f of b minus f of a over b minus a, because you know what the slope is. You know the slope has to be 0. So now I just need to find my derivative. So derivative of sine is a cosine, but what rule do we have to use here? We have to use your chain rule. So what I want to know then is where is c going to be equal to 0? So I just have to take my derivative and set it equal to 0. How do I solve that equation? First of all, what can I do with that 1/2? I can get rid of that 1/2, right? Divide both sides by 1/2. So I have 0 is equal to the cosine of c over 2. Your favorite type of trig equations, remember when you have that operation inside of a trig function, you want to do that substitution. Let's let x be equal to c over 2. Let's find where cosine of x is equal to 0. So where's cosine equal to 0? From the unit circle, it's going to be what? Pi over 2 and 3 pi over 2. So remember, you're then going to bring back this c over 2, take c over 2, and set it equal to pi over 2 plus that 2 pi k. Then what? Multiply both sides by 2. So c is equal to pi plus 4 pi k. So I know c is going to be equal to pi. Always make sure that this c value falls in the interval that's given. So is pi between pi over 2 and 3 pi over 2? Yes, so I know one of my answers is going to be pi. Remember, with these general trig functions, you not only have to check for pi over 2, you have to use the other angle that you found. So you have to take your c over 2, set it equal to 3 pi over 2 plus 2 pi k. But as you can see, if you solve for c here and you multiply by 2, c is equal to 3 pi plus 4 pi k. And we know that 3 pi is not going to be between pi over 2 and 3 pi over 2. So you only have one location where you're going to have a horizontal tangent line, and that's at c is equal to pi or x is equal to pi. So any questions about your mean value theorem or your Rolle's theorem? Let's see. You also have to be able to do this graphically as well. So if you have a ruler or a straight edge, it may be helpful to take it out. The edge of your calculator, or there's my ruler. So like I mentioned, a lot of these calculus concepts you have to do not only algebraically, but from tables and graphically. So this is going to be a graphical application of the mean value theorem. So we're given the graph of f, and we want to estimate. Again, they're going to be estimates from the graph, so reasonable estimations. All the c values in the stated interval that satisfy the conclusion of the mean value theorem or Rolle's theorem, and state whether it's the mean value theorem or Rolle's theorem. So first of all, what you want to do is we're only looking at the closed interval -3 to 1. So you want to put a point on the graph where x is equal to -3. So there's that point right there. X equals 1. Find the point on the graph where x is equal to 1. What I want to do is, using your ruler or your straight edge, we're actually going to sketch the secant line. First of all, now that you see what that secant line is going to be, is this going to be a mean value theorem or is this going to be a Rolle's theorem? Mean value theorem. How come I know it's not a Rolle's theorem? It's not a horizontal. I'm not looking at a line that has a slope of 0. So now I want to find, so the easiest way to do this is I want to take my ruler, my straight edge, and I want to mark the places where it appears that the slope of my tangent line will be equal to the slope of the secant line. So one obvious place I think is right about there. So then just kind of take your ruler with the same slope and slide it up. Remember, you're only looking between -3 and 1, so it appears I'm going to have a spot right about here. Right? And then if I keep sliding it up, it appears I'm going to have another place right about there. So it appears between -3 and 1, I'm going to have 3 places where the slope of my tangent line is equal to the slope of my secant line. So any questions on how I mark that? So now we're just going to approximate the 3 c values. This is where the approximation comes in. So looking right here, and I tend to round to quarters. I would do like 0.25, 0.5, 0.75. When I'm doing my estimations, that seems to be the markers that I use. So right about here, it appears that I'm going to be right around -2.5. If you said -2.6, that's reasonable. If you said -2.4, that's reasonable. If you said -0.5, that's not reasonable. So something around -2.5 would be a reasonable estimation. The next one, right about here, looks like it's probably about -1.5. And then finally, my third spot would be right about here, so I would say about 0.25. Again, remember when they're talking about c values, you're looking for particular x values. So you're looking for particular x values when they ask for those c values. Okay? So any questions on how we can use the mean value theorem graphically? Yes, Alan?
Wouldn't we have one more point at the end of the graph?
But we're only looking between -3 and 1. So now let's look from -1 to 2. So let's find the point at x equals -1, and then at x equals 2. So what do you think? Mean value theorem or Rolle's theorem? Mean value theorem. Again, remind me again, how do I know it's not Rolle's? Not horizontal. Okay? And remember, I'm only looking between -1 and 2. So again, if I take my rule and I kind of slide it down, looks like I'm going to have a spot right about here. Again, slide it down, and I'll have a point right about there. Oops, my markers. Right about there. So for my first one, it looks like it's going to be right about here, which looks like it's about -0.25. And right about here, looks like it's going to be about 1.25. Okay? You guys go ahead and try letter C for me. Be Rolle's, or is it going to be mean value theorem? Rolle's. So rolls, it's a little bit more obvious as to where those slope of those tangent lines are going to be 0. So I know I'll have one here. I'm going to have one here, one here, one down here, and one up here. So 1, 2, 3, 4, 5 places. So right here, it looks like that's going to probably be about negative 2.5. This one right here is probably about negative 1.25. Right here, it's about negative 0.25. What would this one be right here? What do you think, guys? A good estimation. What do you think about this fourth one right here? 1.25 or 1.3, 1.4. And then finally the last one right up here, maybe about 2.75. So any questions using rolls or a mean value theorem from a graph? All right, I will see you guys after lunch then.